Now we want to look at this notion of infinite limits and vertical asymptotes. And our first example is really the prototypical one. It's the basic hyperbola from your library of functions. So this has just got two branches, right? Here's the first branch, here's the second one. And so we want to ask the question, what is the limit as x approaches 0 of this function, let's say from the left? So as x gets close to 0 from the left, the function grows without bound in the negative direction, right? So becomes more and more negative. So in this case, we say the limit as x approaches 0 from the left then is negative infinity. So it's okay to answer with infinity in this case. And then the limit as x approaches 0 from the right. What is that? Well, as we get closer and closer to 0 from the right, the function grows without bound in the positive direction, so we will say the limit as x approaches 0 in this case is positive infinity. Now, according to our convention, the left-hand limit is negative infinity, the right-hand limit is positive infinity, therefore the two-sided limit as x approaches 0, what is that going to be? Well, it does not exist. This thing is different than this thing. And remember, in order for the two-sided limit to exist, both of these must be the same, even in the infinite case. So here we will write, this thing does not exist. If you answer infinity, plus or minus infinity to either side, you don't need both, but if you answer plus or minus infinity to either side, then we will say the function has a vertical asymptote at x equals a. So if either side is infinite, then there is a vertical asymptote at x equals a. So in this situation, there is a vertical asymptote at x equals 0. We could have answered that right from this first evaluation or from this one. We didn't need both of these to be infinite, we only needed one. So the fact that this left-hand limit is infinite, we know there is a vertical asymptote at 0. Okay, let's look at one more sort of basic example like this. Here's another similar example, at least algebraically speaking. So here instead of 1 over x, we've just got 1 over x squared. So now that we've squared the denominator, this fraction is positive. So we take that branch that was negative in the previous example and now just make it positive. So 1 over x squared looks like this. So now the limit as x approaches 0 from the left, again, this thing grows without bound in the positive direction. So that left-hand limit is positive infinity. Similarly, the right-hand limit, as x approaches 0 from the right, the function grows without bound in the positive direction. So the right-hand limit, in this case, is positive infinity. Because these two things are the same, right? Both one-sided limits are equal. That means the two-sided limit exists, even if it's infinite in our case. The two-sided limit exists, and we say that the limit in this case is positive infinity. So, and again, we've got a vertical asymptote at x equals 0. We only needed to check one of these to ascertain that we do in fact have a vertical asymptote. Okay, before we launch into our examples, it would be good to keep the following in mind. So if we've got a fraction, limit as x approaches a of f of x over g of x. And let's say you plug in the number and you get something of the form c over 0 where c is not equal to 0. First of all, this thing is undefined. It has no meaning. Here's what we really mean. We mean that the constant, the numerator, is fixed and the denominator is getting smaller and smaller and smaller. So what happens to a fraction when the denominator gets smaller and smaller? Well, the fraction gets larger and larger. You can write down an example like 1 over 2 is bigger than 1 over 5, and 1 over 5 is bigger than 1 over 10, right? So the denominators get larger, the fractions get smaller, and the reverse is true. The smaller the denominator get, the smaller the denominators get, the larger the fraction will get. So here we've got a very small denominator and a fixed numerator, so we should expect that this ratio is either very large, so positive infinity, or very large in the negative direction, negative infinity. So we just need to figure out which one, right? How do we figure out which one? So that's what we'll look at in the next several examples. I'll give you a couple of techniques you can use to figure out without having to draw a picture.